Okay, great. We'll get started then. That's your first quiz. I hope it felt okay for most of you. Ideally, I've written the quiz to be very fair in terms of what I've covered in lecture, what was covered in the homework, and what I've described on the page. So there should have been no surprises as to the material that was covered on the quiz. Give me a week to have these graded, so you will get your scores back next week. Please don't email me asking me for the grade on your quiz. I will just ignore those emails. So you will get next week. The quizzes will be waiting for you to be returned, and they will be graded. If you answered every single question correctly, showed all of your work correctly, you will get 30 points on the quiz. As a boost to your grade to help everyone out, I grade the quiz out of 25. So if you get all 30 points, your score will go into the gradebook as 120%, which is incredibly generous if you ask me. And that means you could lose 5 points, which is quite a bit on a 30-point quiz. And what goes into the gradebook is 100%. That said, please don't allow this grade inflation to give you a false sense of confidence, okay? If you were to score 20 points on your quiz, technically in the grade book that goes down as an 80%, which doesn't sound so bad. But 20 points out of 30 is really a 67%, which is a D, okay? So on the quizzes, I give everyone a boost and a bonus, really to help you guys out. At the same time, I want you to be aware of where you stand in the class. So if you get 20 points on the quiz, you should take that as a sign that you need to do some work to improve. On the final exams, I feel the final exams and the midterm exam is a little more challenging than the quizzes. Still very fair, but maybe a little more challenging. So I do this grade boosting to help everyone out. That said, I don't offer any separate extra credit assignments. I know some students, at the end of the course they are failing and they ask me for extra credit. Well, I don't believe in assignments that are not very meaningful that will just give you extra points. Okay? So if you want to do well in the class or pass, you need to prove that you, or demonstrate that you understand the material through the quizzes and the exams. Okay. Are there any questions? Yes?
Do you drop the lowest test grade?
Yes, so there are 4 quizzes, and I will drop the lowest of the 4. Okay? Also as another way to help everyone's grade out. So this is, I feel like I'm being very generous in the scoring. So I do drop the lowest quiz. That means if you are absent for a quiz, your quiz goes down as a 0. That will be the one that's dropped. Okay? That said, this first quiz, in my opinion, is the easiest of the 4 quizzes. So I hope no one's counting on this quiz to be the one to be dropped. I feel like all of the questions were very fair in relation to what I've taught and covered in the homework. Any other questions, comments, feedback? Okay, then we will continue on in Chapter 4. We've covered Chapter 4. And next week we'll do Chapter 5. So chapter 4 is all about describing potential relationships between two numeric variables. So in chapter 3, we learned how to summarize and describe one numeric variable. When you have one numeric variable, you want to summarize the shape or describe the shape. You can calculate summary statistics for the center, whether that be the mean or the median. And you can calculate summary statistics for the spread, whether that's the standard deviation, IQR, or range. And you also learned about outliers and anything unusual. So chapter 3 was all about describing or summarizing one numeric variable. In chapter 4, we extend that a little bit by saying, let's have two numeric variables. How can we describe a relationship between two numeric variables? So there's a difference between describing two numeric variables one at a time. Okay? Two numeric variables one at a time can be covered with what we did in chapter 3. Because in chapter 3 we learned how to describe one numeric variable at a time. If we were talking about describing two numeric variables one at a time, that was all covered in chapter 3. Chapter 4 says, let's look at two numeric variables together and the relationship that may or may not exist between two numeric variables. It's very important that we are dealing with numeric variables, and that both of them are numeric variables. If one of the variables is not numeric, or if both of the variables are not numeric, meaning that they are categorical, then all of this stuff that we are going to learn today does not apply. The things we learned today applies only to a relationship between two numeric variables. Later on in the course, we will learn how to describe, a relationship or an association between a numeric variable and a categorical variable. But keep in mind, this stuff only applies when we are describing a relationship between two numeric variables. Okay? All right. When we're looking at a relationship between two numeric variables, that means each case in our data has values for both numeric variables. So it's important that we kind of think of what our data looks like in the first place so that we have an understanding of why these relationships may even be meaningful. So, for example, we can look at individuals. So one example, we can look at individuals and we measure each person's the height and weight. Height and weight are both numeric variables, and each person, or each case, has values for both of those variables. So our data might look something like this. Person, this person's height, this this person's weight. So we have Adam, who is 5'9" and weighs 165 pounds. We have Mary, who's 5'3" and weighs 125 pounds. And Joe is 5'10" and weighs 180 pounds, etc., etc., etc. Okay? Technically, the heights we would turn to just straight inches, so 69 inches, 63 inches, and 70 inches. But in both variables are numeric. And we would look at the relationship between the numeric variable's height and the numeric variable weight. And we can imagine more data points. Okay, so more people with more measurements. Is that okay? Or we could ask, we can go to the county clerk and we say, can you give us a selection of marriage records? Okay, so we can look at.
This is another example.
This is another example. Okay. Now we say, let's look at some marriage records, and I want you to tell me the age of, well, the husband, or I suppose it doesn't have to be husband and wife, but so we'll just say person 1 and person 2 in the marriage record. Okay, so person 1, person 2. Okay, and then so we have each couple, the name of the couple, and maybe the husband or the person 1 is 27 and 25, and maybe we have 33 and 30. Maybe we have 24, 26, so on and so forth. Does this make sense? Okay, so we are looking at data where we have two numeric variables. And we want to ask the question, is there a relationship, overall, is there a general trend or relationship between the two numeric variables? Okay, so the first example, when we were looking at height versus weight, or height and weight, do you think we would see a relationship between the height and weights of different people? Yeah? Okay, what would that general relationship be?
The taller they are, the heavier
Okay, so overall, the general trend would be people who are taller than average probably weigh more than average. People who are shorter than average, we expect, would weigh less than average. That's not always going to be the case. We're going to have tall people who weigh less, short people who weigh more, but overall, if we looked at everybody as a whole, the general trend would be that taller people seem to weigh more, shorter people generally weigh less. Okay? So height and weight, we would say, in general, of course, there will be exceptions to this general trend, but that is the general trend. What about the marriage records? So just for simplicity, let's just say, would we see a relationship between the age of the husband and the age of the wife? Overall. Yes? No? What do you think?
In general, the husband is older. Is that what you're asking?
We're asking for a relationship. Okay, so you are making an observation which is true, but that is not actually what we're asking for the trend. The overall trend that we would see is that generally older husbands generally would marry older women in general. Okay, in general, if a man is younger than average, we would expect his wife to be younger than average also. If we see a man who is older than average, we would expect his wife to be older than average as well. Not necessarily, this one, the trend may not be super strong. We will see some older males marrying younger women, or younger males marrying older women. But in general, couples that marry generally marry people similar in a similar age bracket, I would say. Okay, so we would see that appear in our trend. Is that, are we in agreement there? Okay. So for marriage ages, we would also see in general older husbands have or marry wives or women who are older than average. And in general, I guess younger men marry women who are younger than average. And of course, there will be exceptions, or what we might consider outliers in these trends.
Professor,
Yes?
are we doing person 1 and person 2?
Yeah, I did, for simplicity, I switched to men and women. I hope that's not, I'm not trying to make any kind of political statement or anything like that. Just for simplicity, I just going with that, okay? I know it doesn't have to necessarily be husband and wife. Well, I guess it depends on what state, and, you know, that's a whole nother topic that is not relevant to the issue of linear relationships, okay? So one tool that we have to illustrate these relationships is the scatter plot. on the scatter plot, we would put one variable, one numeric variable, so we could look at the height of a person on the x-axis. And on the vertical axis, we could look at the weight of the person. Okay. So what we would go through and we would plot data points. So if we have a person who is 5'6" and 130 pounds, it would be a, let's see, 64, 66, 8. So 5'6" is 66 inches. What did I say, 130 pounds? That would be a dot right there. Yeah, 66 inches and 130 pounds. That's one person right there. That person would appear as a dot. Maybe we have someone who is 6 feet tall and weighs 200 pounds. So that person is 72 inches, weighs 200 pounds. And so we would have a dot right there. 72, 200. I'm getting some confused with this. Is this okay? Putting dots up. Each dot is a person. Each person has two numbers, a height and a weight, and we're just graphing them as coordinate pairs. So far, so good? Yeah. Okay. And so maybe we have somebody who's 5'10" and weighs 180 pounds, so 70 inches and 180 pounds, and they would have a dot right there. Okay? Maybe we have someone who's 5'10" and weighs 200 pounds. That person would be a dot up there. Maybe we have someone who's 5'11" and weighs 160 pounds. This person would be a dot right there. I don't know if I did that too quickly. I'm just throwing up more examples of people. Okay? And we could just say more and more dots, and we might see an overall trend, something like this. Does that seem okay? So this just represents a lot of people. Each of them has a height and a weight, and we are graphing them as coordinate pairs. So even though we have an understanding of the height and weight, and we said taller people weigh more and shorter people weigh less in general, if these were two variables that we were not familiar with, let's say we were aliens from another planet, and we did not know, if we graphed this, we would see the points forming kind of this scattered zone here. But overall, we would see a general trend that I can kind of draw an oval around. And this would appear as our general trend. Does that seem okay? Okay. And so, by producing a scatter plot, we can see the general trend. Okay. And so, what both height and weight and marriage ages, these are examples of positive trends or positive relationships. Okay? So if the general trend goes in this direction, okay, and the steepness doesn't quite matter, we have a positive relationship. And a positive relationship is defined as such. We are saying that values that are larger than average for one variable, or points that are larger than average for one variable tend to have larger than average values for the other variable. And the flip of that is also true. Points that are smaller than average for one variable would generally have smaller than average values for the other variable. So that would be a positive relationship. So things like height and weight, marriage ages in general, these would show positive relationships. If the general trend looks like this, then we have a negative relationship. And that's kind of the opposite. So points with large values for one variable generally have small values for the other variable. Think of any two numeric variables that might have a negative relationship. Yes?
The last people eat, the last people wait.
I would say that would be a positive relationship, okay? Because positive is large values are associated with large values, small values are associated with small values, okay? So a negative relationship is large values are associated with small ones, and small ones are associated with large ones. Yes?
I guess the amount of gas you have in your tank and the amount of miles your car can drive with that amount of gas. Like it'll go lower.
So again, that's a positive relationship. If you have more gas, you can drive further.
No, like as the gas runs out, the amount of miles that you could drive goes slower.
Okay, so what you are saying is a positive relationship. I could flip this around and it will become a negative relationship, okay? What you are saying is the amount of gas you have in the tank compared to how many more miles you can drive. Is that what you're saying?
Yeah, I could
So that
see-
means if you have less gas, you can drive less. If you have more gas, you can drive more. That would be a positive relationship. Okay? On the other hand, I could flip this around and say, how many miles have you driven versus how much gas is in your tank? So if you've driven many miles, so if you have a large value for miles driven, how much gas would you have left in your tank? Little, right? On the other hand, if you haven't driven very far, how much gas would you have in your tank? A lot. Does that make sense? So that would be a negative relationship, okay? So distance traveled.
This is an example of a negative relationship.
This is an example of a negative relationship. Distance traveled and amount of gas left in tank. Meaning, in general, if you've traveled a lot, traveled many miles, you will have less fuel remaining. If you have not traveled very much, you'll have more fuel remaining. Does that make sense as an example of a negative relationship? Yes.
So for the second one where you said, if you were to graph that in a better touch, the first one would go downward, so how would the second one look? How would the second one
What do you mean by?
look? Like miles traveled and fuel, right?
Uh-huh.
So it goes down. So how would the second one look? As far as like
What do you, I'm sorry,
Like
you say
the-
the second one, but
the
which?
second one as in like the not many miles traveled, and there's still fuel remaining. So how would that look?
Okay, so let's imagine our data. Okay, and we just we have everybody start off with 10 gallons of gas in their tank, and we say do whatever you want this weekend and tell us how far you've traveled and how much gas you have left in the tank. Okay. So person one says I drove 260 miles, and so I have I have half a gallon remaining. And then somebody else says, oh, I traveled 20 miles, and I have 9 gallons remaining. Is this okay? So this is gallons remaining in terms of gas, and this is my mileage traveled. Someone says I traveled 100 miles and I have 6 gallons remaining. And someone else says I traveled 30 miles and I have 8.5 gallons remaining. Okay, and we could imagine more people and more data points. Does this make sense? Okay. And so I will graph this. So across the x-axis, what should I put? Okay, mileage. And I would start where? I would start at 0-ish, okay? And I would go all the way up to, I don't know, maybe 300. And we are looking at how much gas is remaining, and so we go all the way up to 10. So. Okay, so the first person traveled 260 miles and has half a gallon remaining, so they are a point right there. Somebody traveled 20 miles and has 9 gallons remaining, so they have a data point right there. Someone traveled 30 miles and has 8.5 gallons remaining. They are a data point right there. And we have somebody who traveled 100 miles and has 6 gallons remaining. And they are a data point right there. And you could imagine we could gather more data from different people, and depending on their driving habits, we would expect people who've driven more that weekend or whatever would have less gas remaining in the tank. If we can measure that accurately. And so this would be a negative trend, and we see the overall shape should be pointing down this way. Does that answer your question?
Yeah, I was just,
Okay.
I got confused by that.
Okay, so when describing a relationship, we want to talk about the direction. So the direction of the relationship is whether it is positive or negative. Okay, and you need to know what it means to have a positive relationship versus a negative relationship. Hope that's clear to everyone. Another thing we want to talk about is the shape or the form of the relationship. So these examples that I've given so far have been examples of linear relationships. So we have linear shape, and nonlinear. Linear means it can be described by a straight line. Okay, so basically it looks sort of like a straight line. Of course, there's going to be scatter, but overall, a straight line might be able to describe the overall trend. On the other hand, nonlinear means a straight line is not sufficient to describe the relationship. I'm going to draw examples of potential linear relationships. So here's a scatter plot, linear relationship, another scatter plot, So it looks like a straight line to kind of summarize the data. And of course you might have more scatter, but if overall a straight line seems to work, then we can say that's a linear relationship. On the other hand, a nonlinear relationship might look something like this. Okay. A straight line would not work for this. We would need kind of a curve here. So the things we learned today are only useful for linear relationships, okay? Maybe in an advanced statistics course you could learn how to do analysis for nonlinear relationships. But today we're just going to learn how to describe linear relationships. And one thing you want to mention when describing a linear relationship is what? Okay, so obviously if it's linear, you've already described the shape. Positive or negative, the direction, okay? So again, describing variables, or describing relationships between numeric variables, we want to describe the direction, positive or negative. We want to describe the shape, linear or nonlinear. And the last thing we want to describe is the strength. Describe the strength of the relationship. The strength of the relationship can also be thought of as how well can you make a prediction of one variable based on the other variable. So if there's a strong relationship, if you know one variable, you can make a good prediction about the other variable. If there's a weak relationship, your predictions aren't going to be that great. So in a strong relationship, weaker relationship. When we visualize the strength of a relationship, we can summarize it with how much scatter appears in the graph. Strong relationships will have very little scatter. Weak relationships will have more scatter. So you have something like this, how could we describe this relationship?
Strong.
Okay? So we would say a few things. We would say it is linear. It is, what's the direction?
Positive.
Positive. And the relationship is strong. There's very little scatter. If I draw a straight line through it, most of the points are very, very close to the straight line. So there's very little scatter. Okay, over here, how would we describe